To today's webcast, CESMII's webcast, 6 Degrees of Smart Manufacturing. My name is Mike Yost, and I am your host, and I will be joined today by Dr. Sudarsan Rachuri, who's a technology manager at the U.S. Department of Energy. We will welcome Dr. Rachuri here in just a minute, but before we do, I want to take just a minute and give a little bit of background on the webcast itself and logistics of today's event. First of all, people ask, why do we talk about 6 degrees of smart manufacturing? And it's based on the notion that we're only 6 degrees of separation away from knowing every single person on the planet. And so that makes us wonder, how close are we to the information that we need, the knowledge that is needed to make smart manufacturing a reality? We think that we're very close to the information that's needed, and the best way for us to get it is to get connected to as many people with as many different perspectives and as much different experience as possible, so we can learn with and from each other. So in that regard, we're getting people together today, as we have been for the last few months, and taking about the next 20 minutes to go through a discussion and just want to give some logistics about the webcast platform itself. First, you'll note that your lines are muted and will be throughout the webcast. So if you would like to submit questions, you can click on the Q&A button and submit your questions. If we do not get to your questions, we will respond by email, or if you decide afterwards that you want to send a question in, you can send it to my email, which is mike.yost@cesmi.org. Right now, you should be seeing me on your screen in a little window, a little thumbnail. If you don't like the way that thumbnail is presented right now, you can move that around, or you can click on that, and you have different options for making them bigger or smaller, or turning them off altogether. Just one final point is that today's session is being recorded, and it will be posted online within the next coming days. So with that behind us, I want to introduce Dr. Sudarsan Rachuri. As I mentioned, he is a technology manager with the U.S. Department of Energy Advanced Manufacturing Office. He has a long and storied career within smart manufacturing, and has been the editor-in-chief of the ASTM Smart and Sustainable Manufacturing Systems Journal. Was one of the founding members and vice chair of the ASTM Subcommittee on Sustainable Manufacturing, and is also a member of the Smart Manufacturing Advisory Committee. Dr. Rachuri, Sudarsan, if you would, please turn on your microphone and your camera, and welcome to the event here today.
Hello. Good morning to everyone. Thanks, Mike. Thanks for having me here.
We appreciate it very much. And as I mentioned at the intro, we're interested in gathering as many different perspectives as we can on what smart manufacturing looks like to different people. So I will start by just throwing the question to you of, what does smart manufacturing look like to you?
All right. I think this is one of the questions I get asked every time I meet people or give a talk. It's not the question of one definition. It's more like, what is the vision for smart manufacturing? So in that context, I would like to say smart manufacturing is about people, process, and resources, which we have been talking about for quite some time.
Sure.
And added to that, we are talking about adding the cost, quality, throughput, and including the energy resources. How do I optimize the whole system for that? So if you go to the next slide, I have put some quick thought on that, basically to say it's a business, technology, infrastructure, and workforce. So one of the major problem, or I would say major issue for smart manufacturing, is the workforce. How do we train the next generation of engineers, and also the people who are already employed in manufacturing, to understand the right technology? So that's the idea of optimizing enterprise operations. To do that, from my perspective, I thought it is the right information with the right technology, with the right time and the right form, because that's where how you kind of structure your information across different manufacturing systems, and to the people, and to the right people. So this also goes back to some of the issues people are looking at the, most often they are spending a lot of time looking for the right data by the right people. And we don't want this information going to the people who are not supposed to have the right access. And this relates to cybersecurity and not only at the level of encryption and thing, but also who is going to have an access to this information.
Certainly. Well, I think it's a great insight to right from the beginning talk about the people side of things, because oftentimes we get rightfully involved in a conversation around technology because there's a technology component to it, but the technologies absolutely have to serve the people and the systems that need the information, as you've outlined, the right information at the right time in the right form.
Mm-hmm. So I think you touched on a very important point, the word smart, whether you add any adjective before manufacturing, agile manufacturing, lean manufacturing, sustainable manufacturing and things. So when you add smartness, this is exactly what we mean by smartness. How do we make sure this information technology, time, form, and people are well connected?
Right.
As one need. So it's a cyber physical system, if you want to call that way.
Right. Absolutely. Well, fantastic. Excellent. Well, I don't want to steer you through. I know you have another slide or two that you want to touch on.
Yeah. I think it's the right time because you asked that question anyway. So if you move to that next slide, I put some thought into that in terms of what it provides. I was looking at the definition in the previous one, but more in terms of what smart manufacturing can provide. It provides an effective and secure human system platform. So effective meaning it has to be cost effective, it has to be time effective, and it has to be effective in the sense of what is the problem you're trying to solve. And then it has to be secure, right from the device level to the manufacturing system level to the supply chain level, whether it is tier 1 or tier 2 supplier. So how do you make sure it is secure? And human system is very important because we are talking about human in the loop decision making. And the platform is similar to operating system. What is the concept of an operating system for manufacturing? So we have been talking about digital manufacturing for quite some time now. But when you want to go deeper into the level of platform, similar to what we have Windows and Linux and things, if people are developing different apps and things, they need to have a concept of an operating system that where you can connect your machines and equipment and devices and sensors, actuators, and controllers, etc. And better decision making because we are not making decision based on gut feeling and things or making decisions at the last minute, but better decision making in real time, right, with facts, with the data. And if you want to talk to the VP of engineering or plant manager, they are looking at smart manufacturing. How is it going to improve my overall productivity and efficiency?
Right.
And then finally to the networked enterprises, to the supply chain. So this goes back to what we talked in the previous one, the right information, right people, right form and things. So from my perspective, it is more about what is the vision of smart manufacturing than coming out with the one-size-fits-all definition.
Right. Yeah. Well, certainly agree with that as well. And I should have mentioned from the beginning that obviously we collaborate, we work closely together as the Department of Energy is the funding partner, the government partner with CESMII. And so obviously we've been having conversations for a long time on these topics. Just want to go back to the point, and I think folks oftentimes ask the CESMII team, the energy component in smart manufacturing, right? And I agree with the comment that you just made that when you talk to plant managers and you talk to manufacturing people, they're talking about improving overall productivity and efficiency, at scale. So whether it's in their facility or it's across their business or it's across the entire enterprise. So could you maybe touch a little bit on sort of the Department of Energy's interests here and how sort of driving overall productivity drives down to energy productivity?
Mm-hmm. Yeah, it's a very good question. In fact, I just alluded to that a little bit earlier when we had talked about efficiency of resources. It could be material, it could be energy, it could be water. and the energy water material nexus and the overall efficiency of that. But whereas we are talking about energy efficiency, there are two types. One is direct energy efficiency. That is how you are using your equipment, how you are handling your energy resources during the process steps and processing. And then the indirect energy in terms of reducing waste and making sure that you're producing the product right the first time. And more importantly, how you are using your manufacturing equipment more effectively so that your downtime is reduced, predictive maintenance, unscheduled downtime. All of this relates to either direct energy reduction or indirect energy reduction. So energy could be a currency for overall efficiency. Energy is a big factor, but it touches every aspect of it. So that's why we are, from the Department of Energy, we are looking at what is the embedded energy in a product. How you are, for example, energy can be reduced by new process technology or improving process steps or eliminating some process steps or maybe using a better materials for products. So it's a kind of touches all aspects of that.
Right, absolutely, and we certainly see people reflecting that, sometimes going so far as to have energy as a bill of material, as a component of the product that they're making, being able to track that and understand its the cost of energy as a component overall. So. I know you're prepared to talk as well. Maybe just sort of lead you into the next slide that you're prepared to talk about the gaps, right? So what's keeping us, or why do we have to come together in consortium and work together across all the different boundaries of our ecosystem? So you want to talk about the key knowledge gaps?
Yes. Yeah. So you've seen a lot of talk about data-driven and machine learning and sensor technologies. So collecting data from the manufacturing shop floor and the equipment is not new. We have been collecting data for a long time. Right. Process control charts, and all that we have been talking about. But what is the difference now in terms of the convergence of these technologies and advances in computing and machine learning is, in previous cases, if you collect data and then you want to make a decision based on that, you just purely statistics, a simple statistical model. So you will find the average or standard deviation, or in some cases go even to the third and fourth moment, which is for the crookedness and how it is crooked and things like that, whether it is off target or not, the skewness and kurtosis. But what we are talking now is from the actual measurement and how can I understand the system better and model the prediction. So this is where I just wanted to talk about a little bit. If you know the physics of the process, in chemical engineering, they have mass balance and energy balance and all that they have, and they can derive the equations for predicting whatever they are trying to predict. For example, they want to predict the overall efficiency of the product production and things. Or if it is, suppose you are making beer, they want to find, what is the quality in terms of the taste and things.
Sure.
So they have better models in some cases, but may not, even if you have modeled all the physics and things, but sometimes you don't go the entire boundary conditions and everything. So they'll reduce that model to, a physics-based model, so much more simpler case. Or it could be a pre-calculated model or lookup tables, or it could be engineering models. So while we are adding to that data-driven models, in terms of if I have a quantity of interest, for example, exit temperature of aluminum slab or something, how can you understand that from the sensors and collecting the data? Even if the physics is good enough, what more you can learn from the data-driven model, and combining these two models is the one that is the gap here. The foundational problem is, when can you say a system is learnable? How can you understand better from the measurement? People who are very familiar with this, and Kalman filter is one of the earlier example of that. So in addition to this, if you want to have a system level understanding, we can look at it from the agent-based modeling. We need to have stochastic and Bayesian modeling. neural networks and support vector machines and all those things are okay, but we need to understand how can I do the verification and validation. And then network, because we are talking about supply network, everything is connected to everything else in terms of Internet of Things. So how do I model that? And finally, because we are talking about cost, quality, throughput, and also the energy and efficiency and things. So then you need a different types of modeling, game theoretical modeling and stochastic modeling. So this foundational problems and connecting all of them and integrating as a science-based models is the one that, it's very interesting to solve. This will change the way that we look at manufacturing, not just because we can collect data and things, but, foundational understanding of manufacturing.
So how do we, one of the things that, and I've told you this before, one of the things that I love about the ecosystem that we have is that there's so many different aspects to it, right? I come from a background that is much more data-driven, right? And don't have the depth of understanding of the different areas that you're talking about. So coming together here with people from different perspectives, I think is critical to us understanding these different principles, these different models, how they interact, how they help each other toward the end. So how do you see operationalizing this, right? There's a lot of models here. There's a lot of different theory here. So there's a lot of stuff that needs to be worked out academically. How do we go from those types of discussions into actually, systems and solutions and technology and models and such that that end up deployed and useful for folks? Oh, Sudarsan, I do believe we lost your phone connection. Okay, historically within CESMII, we have a rule that if we have dead air, that somebody has to tell a joke. But since I'm the only one on air right now, I'm going to break that rule and just try to buy some time for Sudarsan to come back and join us. Probably one of the ironic things that a situation like this affords us the opportunity is to talk about how, as we talk about technology, sometimes technology lets us down. So in this case, obviously we have lost the audio connection with Sudarsan.
Oh, sorry about that. I don't know, somehow it said the meeting ended.
Oh, geez. Not a problem at all. Okay. Well, actually, I warned you as we were talking earlier that the time we had together is going to fly, and we only have about 2 minutes left. So maybe you just want to touch on this, and then I'd like to give you the chance to give everybody a final takeaway. So maybe the next 60 seconds or so, how you'd like to summarize.
Yeah, if you can quickly show the slide where you are talked about operationalizing it. This is one of the important things. There are different layers to this. I want to now talk about our CESMII a little bit because the RFP1 looked at what are the manufacturing processes problems. What is the end-to-end? Where are the opportunities for optimizing, and how can we understand processes from the measurements, and what kind of physics-based models are already existing, what kind of data-driven models are existing. So important aspect of operationalizing it, you have to be balancing it between research-based solutions in some pieces of software that we need to develop, and also balancing it with the commercially existing software. Okay. And more importantly, how do I connect it to standards and protocols, whether it is a machine-to-machine communication or device-level protocols. So those are at the level of understanding how do I connect them. But then there is another set of standards that we need to worry about. How do I structure my content? Suppose I'm sending empty connect data, for example, machining process information, or at the level of steel making. How are they structuring that information so that it can be used for predictions? Right. Understanding what, not just the regression models and correlation, but also to the level of causation. That's where, combining the physics and the sensor technologies. And more importantly, how can you look at small, medium enterprises who are now producing pieces of artifacts, whether it be physical artifacts or otherwise, and also software artifacts. They are providing both of that to OEMs. They are becoming both now. They are one of the companies that I worked with is they are selling some chemicals, but based on that idea, they developed some software. Now they are selling the software even to their competitors. Okay. So which is a way it is changing the way that we are. Everybody it becomes an ecosystem, like you said. Right. And innovation happens because if everybody comes to this and not fighting standard wars and protocol wars, but create this innovation. And I think CESMII is rightly in place in terms of how they develop their roadmap, how they're rolling out their projects, and the kind of members they have. And it is very fitting with what DOE had a vision of what smart manufacturing should be for US, not just for a particular company or anything. And we are not solving a particular problem for a particular company. It's not a point solution, so it cuts across sectors.
Excellent. Well, I appreciate it very much. Certainly, we appreciate the partnership, the vision, the leadership, et cetera. Apologize for the glitch we had there in the middle and for how quickly this time goes. But I really appreciate you being here. And so with that, I just want to remind everybody that if you want to be here and add your voice to the ecosystem, I encourage you to engage with us. Again, you can email me questions, you can ask for specific guests or topics, or you can volunteer yourself to come and join me as a guest in an upcoming webcast. Speaking of the next set of webcasts in March, we have on March 11th, I'll be joined by Pete Sharp, who's a principal consultant with Emerson Automation Solutions. So we'll be back here at the same time. And look forward to seeing everybody again in another webcast. So thank you again and have a great day.
Thank you. Thank you for hosting me. Thank you.
Take care.
Bye.